For our capstone project, we made a carbon algae air scrubber. My name is Samuel Jordan.
My name's Ethan.
And I'm Alex.
Our world has a problem. With rising CO2 and air pollution, poor air quality is becoming all too common, causing numerous health impacts, such as respiratory issues and many other health problems.
How can our project help? Our project's main goal is to filter out carbon dioxide out of the outside air. It does this by utilizing the algae's ability of photosynthesis.
How does it work? First, the air goes through a filtration process. The air is filtered through the biological system, which enhances air quality. Then, the algae will process that air, and it will absorb the CO2 from it and naturally release oxygen. Our build is highly efficient and effective in urban environments, and it reduces CO2 and improves air quality in the surrounding area. It's made to be low maintenance, and it's very durable. It's very sustainable through the uses of renewable energy, solar power, and it won't negatively impact the environment.
Our design has three major components: the structure, the air system, and a solar power system. The air system draws CO2-rich air from the outside and bubbles it up through the algae, releasing clean air out the top. We used 15 feet of tubing and an aquarium pump to do this.
Our project is made up of just under 200 feet of aluminum square bars, just over 90 square feet of aluminum sheet metal, 500 rivets, plexiglass for the windows, and silicone to seal the entire frame. We chose aluminum to build our frame because it's lightweight and strong.
Our project is run off of solar power. To maintain our project, the solar panels will need to produce around 120 volts. Our setup consists of a solar panel connected to an air pump through a power inverter. The main benefit of our project is that we use renewable energy. This is so the environment isn't negatively impacted through our project.
Before we could assemble our project, we needed to cut out bars of aluminum. To do this, we used an angle grinder and cut the bars down to the dimensions we needed and cut 45-degree angles into the ones needed to create a seamless connection.
To attach all the metal bars, we needed to weld. The majority of our time working on the project was used to weld. We self-taught ourselves how to weld through YouTube and testing to see what had the best results. We spent about $1,000 on all the welding equipment needed, which included the argon gas, a spool gun, a welder, and all the protective equipment.
After we finished the frame, there's a lot of open space that we needed to fill. To do this, we ordered sheet metal to fill these gaps. We cut sheet metal with a grinder and measured the dimensions so it would fit the frame perfectly. To match the tank, we ordered plexiglass, and we also cut that with a grinder. To seal the plexiglass to the tank to ensure there's no leakage, we use silicone so it's airtight.
Once we had cut the sheet metal to size, we drilled holes through both the frame and the sheet metal, and using a manual rivet gun, we securely attached them together. Our project required a significant amount of money to run, a grand total of $5,000. $2,000 of those $5,000 was raised through a summer camp that we founded and ran in Alex's garage. During the summer camp, we hosted science experiments such as egg drops, and we taught the kids how to make oobleck and marble launchers. Additionally to this $2,000, the last $3,000 was generously contributed from Mrs. Shuck, who supported us until the end.